Hi everyone! Welcome back. In this video, we continue our journey into the foundational aspects of game and web development. We've peeked into the world of HTTP methods before, and today we are taking another step. In our last discussion, we looked at the GET method, understanding its role, what is great about it, and what weaknesses it has. If you haven't seen that yet, you can find the link to the GET video on the screen now or in the description below. It's a great primer that will enhance your understanding of today's topic. This time, we pivot to another essential HTTP command, the POST method. Let's take a closer look at POST, explore how it carries the hidden conversations of the web away from the public eye. So what exactly is the POST method? POST method is the internet's way of submitting data to be processed to a specified resource. Unlike the GET method, where data is appended to the URL and remains visible, POST sends data within the body of the HTTP request. This means that the information is not displayed in the browser's address bar, offering a more secure way of handling data. But when do we use POST? It's most commonly used when submitting form data or uploading a file. Think of it as filling out a form at the doctor's office. Once you've entered your details, you hand it over, and it's sent securely behind the counter, out of sight. In web terms, this form is sent to the server to be processed, and then the server responds back, often with a new page, acknowledging the receipt and processing of that data. The POST method is crucial for any interaction that involves creating or updating data on the server. Whether it's signing up for a new account, posting a message on a forum, or making an online purchase, POST is behind the scenes, handling the sensitive details securely. But it's not just about security. The POST method does not have restrictions on data size, making it suitable for larger requests. And because the data is not visible in the URL, it keeps our web interactions clean and clutter-free. However, the POST method is not just a one-trick pony. It's a key part of RESTful services in web APIs, enabling a wide range of actions beyond just submitting forms. It's this versatility and security that make POST an indispensable tool in the web developer's arsenal. In essence, while the GET method can be seen as asking a question or retrieving information, POST is about taking action, making changes, and submitting data to be processed. It's the difference between browsing a menu and placing an order. Understanding the POST method and when to use it is a fundamental part of web development. It ensures that we're not only sending data efficiently, but also maintaining the privacy and integrity of the information being transmitted. Now that we've outlined what the POST method is and when we typically use it, let's weigh its advantages and drawbacks. Understanding these will help you decide when it's appropriate to use POST instead of other HTTP methods like GET. Unlike GET requests, where data is appended to the URL and visible, POST requests send data within the body of the HTTP request. This means the data is not exposed in the browser's history or server logs, offering a more secure way of transmitting sensitive information, such as user passwords or personal details. One of the significant advantages of POST is that it doesn't have restrictions on the amount of data you can send. This makes it ideal for scenarios where you need to submit large forms, upload files, or send complex sets of data to the server. POST is not just for submitting form data. It's used in creating or updating resources, making it a cornerstone for RESTful APIs and web services. This versatility allows developers to handle various tasks, from submitting form data to updating a database. Unlike GET requests, you can't bookmark a POST request because the data is not part of the URL. This means users cannot save or share the exact state of a particular action or submission. To process POST requests, your server needs to be set up to handle incoming data and respond accordingly. This can mean additional coding and testing to ensure your application can correctly process and respond to POST requests. POST responses are typically not cached by browsers or proxies. This is by design, as POST requests usually change the server state, and caching could lead to unintended effects. However, this also means that the same POST request made multiple times will result in the server processing it each time, potentially leading to slower response times compared to GET requests, which can be cached. In summary, while the POST method provides enhanced security and flexibility, especially for data-heavy and sensitive operations, it comes with its set of challenges. These include the lack of bookmarking, the necessity for more intricate server-side handling, and the absence of caching, which can affect performance. Understanding these pros and cons will allow you to make more informed decisions when developing your web applications and choosing between using the post or get method, depending on the task. Now, you might be wondering, if the post method is used to submit data and can even update data on the server, why do we have methods like delete and patch or put? It's a great question and touches on the principles of RESTful web services and the HTTP protocols designed to cater to different types of actions and data manipulations. In short, while the post method can indeed be used for creating and sometimes updating resources, the HTTP protocol offers a richer set of methods to more accurately describe the action being taken. These methods not only provides clarity and precision in web development, but also contribute to its security. By using the appropriate HTTP method for the action you're performing, you inherently add a layer of security to your application. For example, by designating that only delete requests are used to remove resources, you ensure that such a significant action can only occur through a specific intentional route. This helps prevent accidental deletions or unauthorized access to deletion functionalities. Similarly, patch and put methods, when properly used, ensure that updates and changes to resources are performed deliberately and explicitly. This avoids the common pitfall of overloading a post method with multiple responsibilities, which can lead to less secure and less maintainable code. By making your code more readable and stick to HTTP standards, you not only achieve better alignment with web development best practices, but also enhance the security and robustness of your applications. This disciplined approach to using HTTP methods can significantly lower risks, especially when combined with other security practices like authentication and authorization checks. We'll delve deeper into delete, patch, and put in future videos, exploring how they differ from post and get and when to use each for clean, effective web development. Let's take a closer look under the hood of the post method to understand its structure and how it functions within the web's machinery. First up, the structure of a post request. A post request is mainly composed of two parts: the headers and the body. Headers contain metadata about the request, such as the content type, which is crucial for the server to understand how to interpret the data sent in the body. For example, a header might indicate that the content type is application JSON, telling the server to expect JSON formatted data. In the description, there are links to Excel sheets that show all the headers that we use in both the request and responses. The body of the request is where the data you want to send is stored. Unlike GET, which appends data to the URL, POST carries its data here, allowing for more security and capacity. Another critical aspect tied to headers is MIME types. MIME stands for Multipurpose Internet Mail Extensions, and it's a standard that indicates the nature and format of a document. This can include text, JSON, XML, or form data. The correct MIME type ensures that the server understands the format of the incoming data and how to process it correctly. Now onto a concept that's central not only to POST, but to all HTTP methods: idempotency. In simple terms, an idempotent HTTP method is one that can be called many times without different outcomes. GET is idempotent, meaning you can make the same GET request repeatedly and the server's state doesn't change. However, POST is not idempotent. If you send a POST request multiple times, it will potentially create multiple resources or trigger the action several times, which is something to be mindful of when developing your applications. All right, let us now touch on statelessness in HTTP, which means that each request from client to server must contain all the information the server needs to fulfill that request, independent of any previous requests. POST fits into this model because each request is self-contained, carrying all necessary data in the body. However, despite the statelessness, sessions and cookies are often used in conjunction with POST requests to maintain user state across multiple requests, especially in web applications. Understanding these technical aspects of the POST method helps in crafting more efficient, secure, and compliant web applications. It's these nuts and bolts that ensure our web applications run smoothly and securely. As we continue to explore the POST method, it's essential to underscore the importance of security in web development. Rushing through code without considering the risks can lead to significant vulnerabilities. So let's delve into some best practices for using POST securely and effectively. This cannot be overstated. Always validate and sanitize user inputs to prevent common web threats such as SQL injection and cross-site scripting, or XSS. Validation involves checking if the inputs meet certain criteria before they're processed, like ensuring an email address is in the correct format. Sanitization goes a step further by cleaning the data, removing any unwanted or malicious content. By rigorously applying these practices, you safeguard your application from malicious data that could corrupt or compromise your systems. When using Post, your data is not visible in the URL, but that doesn't mean it's automatically secure. Data transmitted over HTTP is like sending a postcard. Anyone who intercepts it can read the contents. This is where HTTPS comes in, providing a secure layer through SSL TLS encryption. Always ensure your website uses HTTPS, especially for transactions involving sensitive information. This encryption protects the data in transit, preventing eavesdroppers from intercepting personal details or passwords. Proper error handling is critical in maintaining a secure and user-friendly application. When an error occurs, especially during a post request, how you handle it and what you communicate to the user can make a big difference. Ensure that error messages are clear but don't reveal too much information that could aid potential attackers. For example, instead of saying invalid user ID or password, you could use invalid login details. This avoids giving hints that could be used maliciously. Additionally, provide constructive feedback for form submissions, letting users know if they need to correct something, but again, be mindful not to provide data that could be exploited. Incorporating these best practices into your use of the Post method not only enhances security, but also improves the overall user experience of your web applications. Remember, security is not just a feature, it's a necessity in the development process, integral to the trustworthiness and reliability of your applications. By prioritizing validation and sanitization, enforcing HTTPS, and implementing thoughtful error handling and user feedback, we create safer web environments for everyone. Let's commit to coding responsibly and keeping security at the forefront of our web development projects. While the Post method is a cornerstone of web development, there are several misconceptions that often arise. Let's clear up some of these misunderstandings and discuss when not to use Post to ensure we're all on the same page moving forward. While it's true that Post is commonly used for submitting form data, its utility extends far beyond that. Post is also used for updating data, sending files, and interacting with RESTful APIs. However, the key is understanding that Post should be used for actions that result in a change on the server. If your interaction doesn't involve changing or creating data, then Post might not be the right method to use. It's important to note that the security of Post is not inherently superior to GET. While it's true that Post does not append data to the URL, thus keeping data out of the URL history, this does not mean Post is secure by default. Security comes from how you handle the data, validating and sanitizing inputs using HTTPS and implementing proper authentication and authorization checks. Despite the fact that Post requests do not expose data in the URL like GET requests, they are not inherently private or encrypted. Data sent via Post can be intercepted just like any other HTTP request, if not encrypted with HTTPS. This is a crucial point to understand. Privacy and security depend on using HTTPS and proper security practices, not on the choice between Post and GET. When do we not want to use Post? If you're simply retrieving data without causing any side effects, like updating or deleting data, GET is the appropriate method, not Post. Using Post for data retrieval can lead to unnecessary complications and is not semantically correct according to HTTP standards. Since Post requests do not retain data in the URL, they can't be bookmarked or shared. If you want users to return to a specific state of an application or share a specific resource, GET is the better choice. If the action should be idempotent, meaning it can be repeated without changing the result, then you should not use Post. Instead, consider GET, PUT, or delete, depending on the action you're performing. Understanding these misconceptions and knowing when not to use Post will help you make better decisions in your web development practices, leading to more efficient, clear, and effective code. As we come to the end of our discussion on the Post method, let's recap the key points we've covered today. We looked into what the post method is and how it's structured, including the importance of headers, body, and MIME types. We explored the scenarios where post is used, highlighting its security benefits and versatility beyond just submitting forms. We then tackled the best practices for securely implementing post requests, stressing the critical need for data validation, sanitization, and the use of HTTPS to protect the data in transit. We also emphasized the importance of proper error handling and providing clear, constructive user feedback. Moreover, we cleared up common misconceptions, helping you understand when and why to choose post over other methods and when it's not appropriate to use. The key takeaway: the choice of HTTP methods should be deliberate, based on the action you're performing and the data involved. Each method has its role, and using the right one for the right task is fundamental to creating secure, efficient, and user-friendly web applications. Now, I encourage you to apply what you've learned. Try out making post requests, experiment with different scenarios, and see the results for yourself. Hands-on practice is invaluable in solidifying your understanding and skills. And remember, I'm here to help. If you have any questions, experiences, or insights you'd like to share, please drop them in the comments below. I'd love to hear how you're applying these concepts in your own projects. If you found this video helpful, please give it a thumbs up, share it with others, and subscribe to the channel for more web and game development content. Your support motivates me to create more videos like this. Stay tuned for our next video, where we'll dive into another fascinating aspect of web and game development. You won't want to miss it. Thank you for watching, keep experimenting, and keep coding. Until next time.